Hey everyone, this is one more example of the Euclidean algorithm and unwinding the Euclidean algorithm and how it relates to camp bucks. So I just thought I would do one more example as you are preparing for your final. So in this example, we're going to find the GCD of 462 and 273. And the way that works is, first step is apply the division algorithm, which basically means you can do division, right? 462 divided by 273. So 273 only goes into 462 once. And then if I subtract 462 minus 273, I get 189. Right? So the division algorithm, you could even use repeated subtraction. Just keep subtracting 273 from 462 until you get a number that's less than 273. So here I only had to do it one time because I get a number less than 273 as the remainder, right? So that's that B equals Q times A plus R. And what that means is the division algorithm, or the GCD, the GCD shrinks, right? So I'm going to save some space and not write GCD, greatest common divisor. I'm just going to do the parentheses, the number part, because I don't have a whole lot of room. And that's fine if you do that as well, right? So the GCD, those two would be the same. And now you repeat that. Now your numbers are 273 and 189. So start with 273, repeatedly subtract 189. I think you only have to do that one only once. Right? If you take 273 and subtract off 189, you get 84. So 1 times 189 plus 84 is 273. And then I rewrite the one I just ended with, and now I shrink it. It's the A, comma, the R, right? Keep on repeating that. So 189, okay, if I take 189, I subtract 84, I get a number that's bigger than 84, so I do it again, and I finally get a number that's less. So I had to do it twice, right? The remainder on that one is 21, right? And you could check my math on that. 2 84s plus a 21 gets you a 189, okay? And so that means the 189.84 shrinks down to 84.21. I think one more time should do it because 21 goes evenly into 84. Or if you subtract 21 4 times, you'll get a remainder of 0. So that means we're done. Once you get the remainder of 0, it's going to shrink to 21.0, which is just 21. So here the GCD is 21. Now what I like to do once I get a number is make sure I didn't make any little errors, and so I can do the division, right? If I do in my calculator 462 divided by 21, that works out. It's equal to 22. And then 273 divided by 21, that works out. It's 13. So 21 definitely goes into both numbers. And the result, 22 and 13, have no common factors, which is also another clue that you've got the biggest one. Right? So you have found the largest number that divides evenly into both of those. Okay, so we've got the GCD. Now we want to try this part 2. We want to find M and N such that the GCD is that, or linear combination of 462 and 273 that will get me that number 21. Okay, the way to do that is unwind the algorithm. So what you want to do is take the top 3 division algorithms and solve them for the remainder. You don't have to do the one that has a 0 in it, just the ones with the non-zeros, right? So if I rewrite those, the first one would be 189, right? If you kind of bring this to the other side, is 462 minus 1 times 273. Right, so I'm just bringing this term to the other side. I want to bring that term to the other side. Isolate the 84. 84 is 273 minus 1 times 189. And then this one, 21, is equal to 189 minus 2 times 84. Right? So solve for the remainder. And now we're going to sort of just plug them into each other. So start with the smallest one, because that's the one that has 21 in it. That's the one, that's what you want. You want 21 equals, right? And you're going to plug the next one up into it. So notice this one has 84. You're going to plug that there, right? So when I write this out, 21 equals 1. I'm just copying it. Copy, copy, copy. But when I get to the 84, I replace with what it equals. Right? So kind of just a copy and paste right in there. Okay? So that's substitute. Now we're going to clean up this right side by distributing that negative 2. Right? So 21 equals 189 minus, and I'm never going to do any multiplication. I'm just going to write it as a multiplication problem, right? 2 times 273. I just want to leave it like that. And then negative 2 times negative 1 would be a positive 2. Don't do the multiplication, just leave it 2 times 181. So that's the distribute step. Finally, I'm going to collect like terms. I have 1 189 there and 2 189s there. I'm going to combine those. That's a total of 3 189s. Okay, we have one more step to go because I haven't used this top equation. That's the one with the 189. I'm going to replace the 189 with that. So I have 21 equals 3. Take the 189 out, replace it with 462 minus 1 times 273. And then I have that minus 2 times 273 still there. Okay, so I just replaced 189 with that. That's the substitution step. Next is distribution, the 3. Again, I'm not doing any multiplication, I'm just writing it. 3 times 462. And then 3 times a negative 1 is a negative 3. And then I still have this minus 2 times 273 here. That's the distribution step. Lastly, collect like terms. You have 273s right there. So I have 3 times 462. And a negative 3 and a negative 2 combined to be a negative 5. And there's my final answer. Right? When I get my final answer, I always like to double check it. Right? I just go on my calculator. 3 times 462 minus 5 times 273. That equals 21. So I didn't make any small mistakes. And I've answered what M and N are, right? So if I look back and actually specify what they are, M was the number attached to the 462, N is the 273. So in this case, M is 3, N is negative 5, because there's a minus there. Now, how does this relate to Camp-Buck problems? This is the same question if asked, if you have denominations 462 and 273, A, what is the cheapest item that can be purchased? The cheapest item is always the GCD. So to find the cheapest item, find the GCD, which we did here. The GCD is 21, so the cheapest item that can be purchased at this crazy camp math is 21. How do you purchase that item, right? What is the exchange equation? That's unwinding the algorithm, and it's right here. So to purchase a $21 item, you give 3 $462 bills, and as change, you get 5 $273 bills. Okay, so if you ever have a camp math question, you can always use the division algorithm, the Euclidean algorithm, and unwind it to answer those two questions. Finding the GCD, and then coming up with the exchange equation. An extension of this is now if we give, another question is, what items can be purchased at this camp math. So any item must be a multiple of 21. So 21, 42, 63, 84, etc. Those are the only items that can be purchased at this camp. Has to be a multiple of the GCD. How do you purchase an item? Now that you have this equation, you can use this equation to figure out how to purchase anything, right? So in other words, let's say you had to purchase a $84 item. Sorry, kind of sloppy. But you want to purchase an $84 item. I just figure out, how do I turn a 21 into an 84? And I can see that must be a multiple of 4, right? 21 times 4 is 84. So I can take that entire equation and multiply through by 4. Right? So I'm just going to distribute the 4 throughout. That's 84 there. And here I'm just going to multiply the front numbers. That's 12 462s, 20 273s. So to purchase an $84 item, give 12 462s, get 20 273s in exchange. Once you have this, it's always good to double check it, make sure the math works out right. All right, 12 times 462 minus 20 times 273 does equal 84. Okay, so hopefully that little example can help with some questions relating to Euclidean algorithm, camp math, and all of that. If you have any questions, please let me know. Otherwise, last week, good luck studying, and I'll talk to you later. Thanks. Bye.